Hello everyone, in this video let's discuss about common emitter configuration. So if you are new to our channel, please subscribe for more engineering related topics. In previous video we discussed about common base configuration. So same in common emitter configuration also we will be using PNP transistor. PNP transistor. What is PNP transistor? N type of semiconductor is doped in between two P type of semiconductor. So this type of transistor will be called as PNP transistor. In this common emitter configuration, the emitter will be common between both input and output. Between input and output, emitter will be common. That is, the direction of the emitter current will be this like, and the voltage will be 0. As this is connected to the ground, its voltage will be equal to 0. Left part is called as the input part, right part is called as the output part. So it is common between input and output part. Emitter is common between input and output part. So let's call the input part as the base part. So the resistance will be RB and the voltage will be VBB and current will be IB. So specify the direction. The conventional current will flow from IE to RB or IE to IB, like this it will flow. Next, so the output part will be collector part, that is the current flowing through it will be IC and this resistance will be RC, this voltage will be VCC. Now let us discuss about the current amplification factor, that is DC current gain. DC current gain in common emitter configuration. So it will be represented using beta. We are representing DC current gain, so DC. So its value will be equal to output current divided by input current. So what is the output current? Output current means right side. So what is in the right side current? IC. So IC is the current in right hand side. What is the current in the left hand side? IB. So we should not use the emitter because it is common in between both. So left side, that is input part, that is IB, and output part current is IC. So IC divided by IB will be the current gain. Now let us discuss about the input characteristics and output characteristics graph. First one, input characteristic graph. Input characteristic graph. In input characteristic graph, we will plot the graph against current versus voltage. So while plotting the graph of input characteristic of common emitter configuration, we must know the values of three important components, that is input current, next input voltage and output voltage. Input current, output voltage and input voltage. So what is the value of input current? Input current means left side. What is the current in left side? That is IB. Next, what is the voltage? Voltage means we should take the junction voltage, that is this is base, this is emitter. So VBE, voltage across base emitter junction, and this is emitter and collector junction, that is VCE, that is the voltage between the collector and emitter. So what is the input voltage? That is left side, VBE. What will be the output voltage? That is VCE. So we must keep the output voltage as constant because we are plotting the input characteristic graph. So while plotting up to certain limit, that is up to threshold value, the current will increase slightly, that is slowly. When it crosses the threshold voltage, it will increase sharply. If we consider this as constant voltage VCE, let's consider its value as 5 volt. Next, if I change the value of the constant voltage VCE and increase, if I take VCE value as 10 volt, means it will same come up to here, up to threshold voltage, and increase sharply as the threshold voltage is crossed. So the graph will be here. So we can see that as the VCE, that is constant voltage value, increases, the graph is shifting towards right. So right, shift towards right. The graph is shifting towards right. So this is the input characteristic graph of the common emitter configuration. Now let's plot the output characteristic graph of common emitter configuration. In output characteristic graph also we will be plotting against current and voltage. So here in input side, what is the current? Input current is IB and input voltage is VBE. Here output characteristics, we must take the values of output current, output voltage and input current. Output current, output voltage and input current. So we must be knowing what values we must take. So what is the value of the output current? Output current means right side. What is the value? That is IC. Next, what is the output voltage? VCE. What is the input current? Input current is IB. So therefore we are plotting the graph of the output characteristics. So we must make the input value as constant, that is input current as constant. So output current will be IC versus output voltage will be VCE. So we will be plotting the graph against these two. So when VCE value will be is equal to 0, it will produce small amount of current. It will produce small amount of current, that is ICE, because of this voltage VCE, which will be slightly less. So we don't consider, but we must plot in the graph. Now as I said, let's consider the input current as constant, that is IB value will be constant. First I will take IB value as IB is equal to 10 microampere. Next another value, IB value is equal to 20 microampere. So I consider two cases. So in the common emitter configuration, as the voltage value increases, as the output voltage value increases, the current will increase and it will increase in such a way that the current produced will be more than the constant current we expected. So same as it is, if 20 microampere means it will slowly rise and go more than the expected constant current value. So the part where the current is amplifying or increasing, this part will be called as active region. This will be called as active region. And this part will be called as saturation region. Saturation region. Where the current is not acting, this part will be called as the cutoff region. Cutoff region. So why this current will be produced means ICE, this will be because of the reversing biasing of CB junction. So now if we look at the equation, IC is equal to beta DC into IB. So what is IC? Current at the output side will be equal to the current gain, that is beta DC into the current at the input side. So the value of the beta DC, that is current gain, will be very less. Current gain will be very less. Therefore IC value will almost be equal to IB value, that is IC, that current at the collector side and current at the base side will be almost equal. So hope you understood the concept of common emitter configuration. If you have any doubt, please comment below, and if you like the video, please subscribe for more engineering related topics. Thank you.